Welcome to week 5, new 31 NEW. We are almost through the week and we are going to be solving rational equations this week. This is take 1. We are going to do 2 takes of this topic. So let's get started. Now, I will preface this topic with this. I will not teach you the way the book teaches you. I will probably not teach you the way any other teacher teaches you this, or professor, whatever you want to call us, whatever. However, this is the way I will stand by teaching it because I think it is the most direct. It will not be the quickest way if you want to go into the book and do this. I will tell you right now, looking at what section it is. It is 6.5. So if you want to go ahead and do it the way that the book does it, it is 6.5. It goes into least common, least common denominators, least common multiple, and that stuff. I do not rely on that. I give you the way that you can do this without that. So to each their own. There's nothing wrong with that. The other ways, I am by no means saying that you can't do it that way or that that's not even a better way to do it. This is just the way I rely on that does not rely on that way of doing it. So that's the way I will be teaching you, just so that you know going into it. All right, let's get started. So the way we're going to do this is probably one of the first equations you've seen where you have fractions in it. And you guys all told me at the beginning that you hate fractions, which I hear every semester. You're no different than everyone else. So the whole thing is, regardless of how you learn how to do this, the point is you don't want fractions in the equation that you use. So how do we go from having fractions in our equation to not having fractions in our equation? Well, the first thing is, if we have fractions in some of our pieces, we need to have fractions in all of our pieces. So that one, you want to go through and put anything that's not in a fraction over 1. So that 2, we want to put it over 1. Now, the next thing we want to do is we want to clear out the fractions. So 1, put anything not over 1 over 1. Step 2, clear out fractions. The method to do this is this. All right, you are literally going to take whatever is in the denominator and you are going to multiply it by every piece of this equation. So watch. You have a 5, you have a 3, you have a 1. You are going to multiply this piece by 5, 3, 1. You're going to multiply this piece by 5, 3, and 1. You're going to multiply this piece by 5, 3, and 1. Now, we came up with a really cool trick, week 1, where we said that if you had a 5 on the top and on the bottom in the numerator and the denominator, what happened to them? Yes, they canceled out. They divided to 1. So here, the 5 cancels out with the 5. Here, the 3 cancels out. Ooh, that was a little bit big. Hang on. 3 cancels out with the 3. And here, the 1 cancels out with the 1. So now you've essentially cleared your denominators all the way across. You don't have them anymore because they all canceled out. Now, what does that leave you with? Okay. Here it leaves you with this. Here it leaves you with this. And here it leaves you with this. Okay. So let's kind of figure that out. And there I'm just going to make an equal sign so I kind of know where it is because it's a little messy. All right, so 3 times 1 times 2 times x. So 3 times 1 times 2. The ones you can kind of forget about, right? It's nice. So that's going to be 6x minus 5x equals 5 times 3 times 2. That's 15 times 2, 30. So that's x equals 30. And I'm done. Now, here's the deal. It says state any extraneous solutions right there. Not every single one of these answers is going to work every time. And you're going to be like, well, how do I know? 99% of the time these will work. What's going to happen is they're not going to work when we start getting into variables in the denominator. So we just have to check these working really quick and see if they do work by like plugging it into a calculator. So really quick, like 30 times 2 is 60. 60 divided by 5 is 12. So that's 12 minus 30 divided by 3 is 10. Minus 10 equals 2. Does 12 minus 10 equal 2? Yes. So you're good to go. All right. All we did was plug it back into our original. Okay. Number 2. So we're going to throw a 1 over the 1. And then we're going to clear out. So 4 times 3 times 1. 4 times 3 times 1. 4 times 3 times 1. All right. And then we're going to look for what cancels. 4 and 4. 3 and 3. 1 and 1. Okay. So what do we have? If I kind of highlight, I have that. I have that. I have that. Okay. So there I have 9. Oops. I have 9a minus 8a equals 12. So that's a equals 12. Plug it back in. So that's 36 divided by 4, that's 9, minus 24 divided by 3, that's 8. 9 minus 8 equals 1. Check. All right, so here a little bit different, okay? Same premise, but just a little bit, we have that x minus 1 on the bottom, so let's see how it changes things. It's a package because remember, anytime we have that addition and that subtraction, it messes everything up, quite frankly. All right, so we threw the 3 over 1, and now watch. X minus 1, 5, and 1. X minus 1, 5, and 1. X minus 1, 5, and 1. Okay? Now my order, remember, everything's multiplication, so I can change my order up. This x minus 1 and this x minus 1, this 5 and this 5 and this 1 and this 1. I can throw that too. Okay, so what do I have now? I have this. I have this. And I have this. Okay, so here I have 5 times 3 times 1. That's 15 plus. Now this is 12 times x minus 1 in parentheses. And this over here is 15 times x minus 1. Because see the 3 times the 5 and then this x minus 1. Again, multiplication can go in any order. So I can do the numbers and then I can do this parenthesis at the end. All right, this is not, the order of operation says I have to do this 12 before I do this 15. Okay, so please, 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 multiplication before addition. So I have 15 plus 12x minus 12 equals 15x minus 15. So I have 12x plus 3 equals 15x minus 15. Minus 12x minus 12x. 3 equals 3x minus 15, add 15, add 15, 3x equals 18, divided by 3, x equals 6. Okay, now I have to plug it back in. So I get 3 over 6 is going here, so that's really a 5, right? Because 6 minus 1 plus 12 over 5 equals 3. So let's make sure that works. What is that? That's 15 over 5 equals 3. Well, what's 15 over 5? 3 equals 3. So that checks. Now, could you plug that in your calculator? Absolutely, you can. So far we have not seen an extraneous solution. That's okay. Maybe we will, maybe we won't. Extraneous solutions are not something that's going to happen, most of the time. They're not. That's the exception to the rule. All right. Over 1, package deal. Also a package deal. And now, a plus 9, 4, 1. A plus 9, 4, 1. A plus 9, 4, 1. A plus 9s, 4s, 1. Okay. What do we got left? This, that, that. So just some complicated equations, but not anything we're not factoring here, right? We could be, but we're not. Some of these get really complicated. All right, so we have 4, we have 4 parentheses a plus 2 minus a plus 9, because look, this is just a 1 times a 1 times a plus 9 equals negative 4 a plus 9. Negative 1 times 4 times a plus 9. Okay. So 4a plus 8 minus a minus 9, make sure that distributes, equals negative 4a minus 36. So 3a minus 1 equals negative 4a minus 36. Add 4a, add 4a. 7a minus 1 equals negative 36. Add 1, add 1. 7a equals negative 35. Divide by 7, divide by 7, a equals negative 5. All right, so now, a little bit of work. Negative 5 plus 2, we get negative 3 over negative 5 plus 9, negative 4, positive 4. Okay. Minus 1/4 equals negative 1. Does that equal negative 1? Yes. Good. All right. So go back, practice. When you're ready to move on to take 2, practice some more with me. Go to the next video.